Okay, going to move on to section 3, talking about right triangle trigonometry. This stuff's going to look more familiar. This is what you were doing in geometry and back in algebra 2, applying these trig concepts to right triangles. Just to kind of show you how these things are kind of tied together, if you look at on the left side, we've got the unit circle here. We've got our circle with a radius of 1, and we can drop in this altitude over here on the side. Go back to the pencil. So we can drop in this altitude here, which represents our y, and giving us our right triangle. You can see we have an x distance here, and we've got a y for the height of the triangle. And remembering that in the unit circle, the x is the cosine. And remember also that our y value is equal to the sine of theta. We were using t before. T, theta, u, x, it really doesn't make a difference. It's just a variable. So looking at how these things relate, if we expand this and take our circle and say it's not necessarily a unit circle, but it could be any circle with a radius of r. And we still have this x and we have this y. And how are all these things going to be tied together? Well, the cosine of theta is now x over r. And notice we could still use that same thing in the unit circle, but remember in the unit circle r was 1. So x over 1 just gives me back this cosine of theta being x. So if cosine of theta is x over r and sine of theta is y over r, then we can also think about these things in terms of just the triangles and where are the x and the y located with respect to the theta. Okay? So if we kind of pull that triangle out of the circle and look at it by itself, then the y is what we call the opposite leg, because it is on the opposite side of the triangle from our angle theta. The x, we refer to that as the adjacent leg because it is adjacent to theta. It's right next door. And then the r becomes the hypotenuse of our right triangle. The hypotenuse is always the hypotenuse. Now this idea of opposite and adjacent depends on where the theta is. Okay? If I were to move theta up here into the top angle, then I go over here, this becomes the opposite side, and this one would become the adjacent side. I have a little pen difficulty here. Okay? So we've got this SOHCAHTOA here. We kind of break this up, where the sine is the opposite over the hypotenuse. So we have that relationship right here. The sine of angle theta is the ratio of the opposite leg over the hypotenuse. The cosine is the adjacent over the hypotenuse. So we have that relationship right here. And then tangent is the opposite leg over the adjacent leg. Okay? So we really only need to know those three, because if we use our reciprocal functions and the relationships that we had in the last section, if I wanted to find the cosecant or the secant or the cotangent, then I would just use the reciprocal functions of sine, cosine, and tangent. So I would just take and flip all of those things over. So I don't really need to memorize these three over here. I just need to remember how to get them using those reciprocal functions. Okay. So here, if we look at this, here's a small triangle with an angle theta. I've got a leg of 2 and a leg of 3. So the tangent of theta is going to be 3/2. Okay. Down here I have a larger triangle with an angle theta and sides of 6 and 9. But notice when I take the tangent of theta, I get 9 over 6, but that simplifies to 3/2. So even though my triangles are different sizes, I have one that's clearly bigger than the other, the tangent of the angle is still the same thing. So what that tells us is that the trig values, with the sines, the cosines, the tangents, all those trig values only depend on the size of the theta. They don't depend on how big the triangle is. Okay? Because even though the triangles are different sizes, they still have the same angle measures in them. They would be similar triangles. Okay? So find the value of each trig function of theta. So let's start out. Sine of theta. Okay. Remember we said sine of theta is opposite over hypotenuse. Well, we don't know the hypotenuse, so how can we figure it out? Well, oftentimes we're going to have to use the Pythagorean theorem. Okay. So Pythagorean theorem says 3 squared plus 4 squared would give me that hypotenuse squared. And if we solve that we're going to get the hypotenuse equal to 5. So now I can find sine of theta, which says take the opposite, which is 3, over the hypotenuse, which is 5. The cosine of theta is the adjacent leg, which is 4, over the hypotenuse, which is not 4, but rather 5. And tangent of theta is the opposite leg over the adjacent leg. Okay? So cosecant of theta, remember cosecant is the reciprocal of sine, so that's going to be 5/3. The secant of theta is the reciprocal of cosine, so that's 5/4. And the cotangent of theta, that's the reciprocal of the tangent, so that one becomes 4/3. So you see, I just need to remember the relationships for the three basic sine, cosine, tangent, and then I can use the reciprocal functions, the reciprocal identities, I should say, to figure out cosecant, secant, and cotangent. Now, if you recall from geometry, if I have two angles whose sum is 90 degrees, or we can also use pi over 2 if we're thinking in terms of radians, then those angles are what we call complementary. Okay? And the sine and the cosine are what we call cofunctions. And cosine is really a shortened form of complements sine. So the cosine is really it's a complementing the sine. So on your identity sheet that I gave you in class yesterday, there is a little section that says cofunction identities. So you can just see that half sheet rather than me writing them all out here. But basically what it's saying is if I have the sine of 20 degrees, okay, that's going to be equal to the cosine of 70 degrees. Okay? The sine and the cosine are cofunctions, and 20 and 70 are complementary angles. So those cofunctions of those complementary angles are going to be the same. Okay? So let's just look at one application here. We've got this tree. We've got an angle of 40 degrees to the top of the tree. We're 75 feet away from the base of the tree, and we want to know how tall the tree is. So what we have to do is we have to consider from the angle that we're given, what sides do we know and what sides are we looking for? Well, we're looking for the opposite leg, and we're given the adjacent leg. So I have to think about which of the trig functions relates opposite and adjacent. And that's tangent. Tangent of theta is the opposite leg over the adjacent. So my theta is the 40 degrees. So I know that the tangent of 40 degrees is going to be the opposite, which is h, over the adjacent, which is 75. So how are we going to solve that? Well, we need to get h by itself. So how do I get rid of the fraction? I'm going to multiply both sides by the 75. So 75 times the tangent of 40. So we're going to type that into the calculator. We got to make sure that our calculator is in degree mode because our angle is in degrees. And if we go to the nearest foot, we'd have 63 feet as an approximate height of the tree. Okay? So always remember to check the mode of your calculator. Okay? If the problem you're dealing with has an angle that's in degrees, you need to make sure that the mode is in degrees. If the problem you're dealing with has an angle in radians, then you need to make sure that your calculator is set to radians. Okay? So hopefully this brings back some things that you already learned in your previous classes. So we'll do some more practice with those in class tomorrow.